Now let us take another example. F of x equals to x by x square minus 4. You need to identify intervals so that the given function may be increasing or decreasing. Okay. Let us start with first derivative. Now it is of the form u by v. Denominator will be v square and the numerator will be x square minus 4 into derivative of x is 1, x into derivative of x square minus 4 is 2x. So it is x square minus 2x square minus x square minus 4 by x square minus 4 whole square. Okay. Now you take minus common. It is minus of x square minus 4 by x square minus 4 whole square. Okay. X square plus 4 by x square minus 4 whole square. Okay. So if you take x equals to minus 2, then minus 2 whole square is 4. 4 minus 4, 0. So it does not exist. Whenever x equals to minus 2, the value is not existing. If you take x equals to 2 also, 2 square 4, 4 minus 4, 0. Then also the value is not existing. So it is not existing for minus 2 and 2. Okay. You can see that whether x value is positive or x value is negative, x square is always positive. Okay. Whether x is positive or x is negative, x square is always positive. Positive value plus 4 positive by something whole square, it is also positive. Positive value by positive, it is positive. Positive value into minus sign, it will be negative. Okay. So it will be negative for x may be positive or x may be negative except the values x equals to minus 2 and plus 2. For all x except x equals to minus 2 comma 2. Okay. For minus 2 and 2, it is not existing. For all the other values, this is a negative quantity. Since this is a negative quantity for all the x values, you can conclude that the function is a decreasing function in the interval. Okay. So function is decreasing function is decreasing function for every x except minus 2 comma 2. Okay. Since first derivative is negative, you can conclude that function is decreasing function for every x value except minus 2 comma 2. Okay. So it is same as you need to exclude minus 2 and 2. It will be minus infinity to minus 2 union minus 2 to 2 union 2 to infinity. Okay. If this is the real line, if it is minus 2, it is 0 and it is 2 and it is infinity and it is minus infinity. So you need to exclude minus 2 and 2. So the remaining interval is minus infinity to minus 2 excluding minus 2, then minus 2 to 2 excluding minus 2 and 2, then 2 to infinity. Okay. On these intervals, the given function is decreasing function. Okay. So this value cannot be a positive value. This value cannot be a positive value because of the negative sign. This is already a positive quantity. It is also positive quantity. Positive quantity multiplied by negative sign is a negative quantity. Okay. It cannot be a positive quantity. Hence, the first derivative cannot be positive. Hence, there is no interval so that this function is increasing. Okay. Since this quantity cannot be a positive quantity, so for no x, the given function is an increasing function. So for no interval, f of x is increasing function. Okay. On these intervals, the function is decreasing function and there is no interval so that the function is increasing. Thank you. Now let us see what is second derivative test. Okay, let us see what do you mean by second derivative test. Okay, so the purpose of this test is you can identify maximum or minimum of a given function in the given interval. Okay, you can identify extremes of a function in the given interval. This is the advantage of second derivative test. Suppose a function is given and an interval is given I. It means x takes values from the interval I. Now find the first derivative f of x. First derivative for f of x, it is f dash of x. Then equate it to 0. Equate it to 0. There will be some x values. There will be some x values. Those x values are called critical values, or the other name is stationary values. Okay, at critical value or at stationary value, the maximum or minimum of a function may or may not exist. Okay, now let us find second derivative for the same function. Okay, so that is f double dash of x. If this derivative is positive, for a particular stationary value, or critical value, okay, then we can say that the function has minimum at that particular critical value. Okay, a function is given and we have taken its first derivative and equated to 0. You got some x values. Those x values are called critical values or stationary values. Critical value or stationary value is the one where the maximum or minimum of a given function may or may not exist. Now let us consider second derivative. If the second derivative is positive for a particular critical value, then at that particular critical value the function has minimum. Okay, at that critical value function has minimum. Okay, suppose the critical value is x naught. X naught is a number. Okay, and correspondingly f double dash of x naught is positive, then we can say that at x naught f of x has minimum. We can say that at x naught f of x has minimum. Okay, suppose f double dash of x naught is negative, where x naught is some critical value. Okay, then we can conclude that f has maximum at the critical value x naught. Okay, so a function has maximum at the critical value x naught if f double dash of x naught is negative, maximum if f double dash of x naught is negative, where x naught is the critical value, and the function has minimum if f double dash of x naught is positive, where x naught is the critical value. Critical value can be obtained by equating the first derivative of the function to 0. Okay, by equating the first derivative to 0, you can have the critical value. The alternative name for critical value is stationary value. Okay, so this comes under second derivative test. The purpose of this test is you can identify maximum or minimum of a given function if exists. Let us consider this example. Find the maximum or minimum value of x so that this function is maximum. Identify the values of x so that this function is either maximum or minimum by using second derivative test. okay, by using second derivative test. Okay, now let us apply second derivative test. Consider the given function. It is 7x square minus 3x plus 5 and its first derivative is 14x minus 3. Now equate it to 0. So on equating to 0, we will get x values, and those x values are called critical values or stationary values. At those values, the maximum or minimum of the given function may or may not exist. It implies x equals to 3 by 14. Okay. Now 3 by 14 is the stationary value, or it can be also called as critical value or critical value. Okay. Now find second derivative. It is f double dash of x. It is equals to 14 into 1. It is 14 and it is a positive quantity. For any x value, it is a positive quantity. For the critical value 3 by 14 also, it is positive. So at this critical value 3 by 14, the second derivative is positive. Since the second derivative is positive at the critical value, so you can conclude that the function has minimum at this critical value. So f has minimum at x equals to, function has minimum at x equals to 3 by 14. Okay. So at 3 by 14, this particular function has minimum value. Okay. So for no x, this function can be negative, so that it implies that this function has no maximum. Okay. For no x value, this quantity is negative, so second derivative cannot be negative, so it implies that the function has no maximum. Okay. Now the conclusion part. So we have identified that at x equal to 3 by 14, we have minimum, and you need to find minimum value also. So minimum value is f of 3 by 14. It is equals to 7 into 3 by 14 whole square minus 3 into 3 by 14 plus 5. Okay. So it is 7 into 9 by 196 minus 9 by 14 plus 5. So denominator is 196, 63 minus 14 into 9, it is 126 plus 5. It is 68 minus 126 by 196. It is equals to minus 56 by 196. So it is the minimum value corresponding to the function 7x square minus 3x plus 5 at x equals to 3 by 14. So this function has minimum at 3 by 14 and it has maximum for no x value. Thank you. Now let us consider another example. F of x equals to x cube minus 2x square plus x plus 1. Now you need to identify maximum value or minimum value for this function by using second derivative test. Okay. Now let us start with the first derivative. It is 3x square minus 4x plus 1. Now equate it to 0. It is 3x square minus 3x minus x plus 1 equals to 0. Taking 3x common, x minus 1, taking minus 1 common, x minus 1, 0. So x values are 1 and 1 by 3. Okay. So these are called stationary values or critical values. Now at these values, the maximum or minimum may or may not exist. Now consider second derivative. It is 6x minus 4. Now Evaluate second derivative at 1. It is 6 minus 4, it is 2, positive. So second derivative is positive at x equals to 1. Since the second derivative value is positive, so you can say that the function has minimum at x equals to 1. So function has minimum at x equals to 1. You need to write minimum value also. And the minimum value is f of 1. It will be equals to, substitute in the given function, 1 minus 2 plus 1 plus 1, it is equals to 1. So 1 is the minimum value corresponding to the given function. There is another stationary value also, that is 1 by 3. Substitute it in the second derivative. Now f double dash of 1 by 3, it is 6 into 1 by 3 minus 4. It implies 2 minus 4, it is minus 2, and the quantity is negative. Since the second derivative is negative, so you can say that function has maximum at the stationary value 1 by 3. Since the second derivative is negative, so f has maximum at x equals to 1 by 3. Okay, so you need to identify maximum value also. And the maximum value is f of 1 by 3. It is equals to, substitute in the given function, it is equals to 1 by 27 minus 2 into 1 by 9 plus 1 by 3 plus 1. It is 27, 1 minus 6 plus 9 plus 27, and it is equals to 31 by 27. So this is the functional value, or this is the maximum value for the given function corresponding to the stationary value 1 by 3. Given f of x is equals to x square plus 2x minus 3, now we need to find maximum and minimum of this function f of x by using second derivative test. Find maximum or minimum of f of x by using second derivative test. Okay, now let us consider the given function f of x is equals to x square plus 2x minus 3. Differentiate this function with respect to x. Then it is equals to 2x plus 2 and equate it to 0. This is implies x equals to minus 1. So minus 1 is the critical value. It is the critical value of f of x. At this value, the maximum or minimum of function may exist. Now consider f double dash of x. This is equals to 2, and it is positive when x is equals to minus 1. So we can conclude that f has minimum at x equals to minus 1. Since f double dash of minus 1 is positive, so you can conclude that the function has minimum at x equals to minus 1, and also the minimum value is f of minus 1. This is equals to minus 1 square, 2 into minus 1 minus 3. It is 1 minus 2 minus 3. It is 1 minus 5 minus 4. So minus 4 is the minimum value corresponding to the function f of x equals to x square plus 2x minus 3. Since there are no other critical values, so about maximum you cannot decide here. Now let us take the function f of x equals to 2 minus x whole cube. You need to find maximum or minimum of this function by using second derivative test. So find maximum or minimum of f of x using second derivative test. Now let us start with the derivative. Derivative is 3 into 2 minus x whole square, and internal derivative of 2 minus x is minus 1. Now equate this term to 0, then it will be 2 minus x whole square equals to 0, and it implies x equals to 2. So at 2, the maximum or minimum of f of x may exist, and this value is called critical value or stationary value. This is called critical value. Now let us find the second derivative. Second derivative is minus 3 into 2 into 2 minus x, and internal derivative of 2 minus x is minus 1. So this is 6 into 2 minus x. Now find f double dash at the value 2. This is equals to 6 into 2 minus 2. It is equals to 0. Since second derivative value is 0, you cannot decide whether the function has maximum or minimum at this value. So the test fails here. Thank you. Now let us start finding f dash of x. This is equals to x cube derivative 3x square minus 6 into x square derivative 2x plus 9 into x derivative 1. It is 3x square minus 12x plus 9, and equate this to 0. Now this is x square minus 4x plus 3 equals to 0, and the roots are 1 and 3. Okay, so 1 and 3 are called critical values. They are called critical values, and at these values the maxima or minima of the given function may exist. Now find second derivative. This is 6x minus 12 plus 0. Now find f double dash at 1. It is 6 minus 12. It is minus 6 negative. Since second derivative evaluated at x equals to 1 is negative, so you can say that f has maximum at x equals to 1. F has maximum at x equals to 1, and you need to find maximum value, and the maximum value is f of 1. So write x equals to 1 in the given function. It will be 1 cube minus 6 into 1 square plus 9 into 1 minus 8. It is 1 minus 6 plus 9 minus 8. It is 10 minus 14. It is minus 4. Minus 4 is the maximum value of the given function. Now evaluate f double dash of x at x equals to 3. Now f double dash of 3, this is equals to 6 into 3 minus 12, and this is 18 minus 12 positive. Since second derivative value is positive, so you can say that f has minimum at x equals to 3. Minimum at x equals to 3, and also you need to find minimum value, and minimum value is f of 3. This is equals to 3 cube minus 6 into 3 square plus 9 into 3 minus 8. This is 27 minus 6 into 9 54 plus 27 minus 8, and it is equals to minus 8. Minus 8 is the minimum value for the function f of x, and this is equals to minus 8. Now let us consider another example. F of x equals to x square minus 4 whole square. Now you need to find maximum or minimum for this function by using second derivative test. So find maximum or minimum of f of x by second derivative test. Now let us start with f dash of x. This is equals to 2 into x square minus 4 and internal derivative is 2x. Now equate this to 0. Now this implies x equals to 0, x equals to 2 and minus 2. Now these are called critical values, and at these values the maximum or minimum of the given function may exist. Now find second derivative. It is 4 into d by dx of x cube minus 4x. Now it is 4 into 3x square minus 4. Now find second derivative value at 0. This is equals to minus 16 and it is negative value. Since second derivative is negative, you can say that the function has maximum at x equals to 0 and the maximum value is f of 0 and it is equals to 16. Now f double dash at x equals to 2. At x equals to 2, it is 4 minus 4, 0 whole square, it is 0. Since the function value, since the second derivative value is 0, so the test fails here. Okay. Also at x equals to minus 2, the function value is 0, second derivative value is 0. Here also the test fails to determine whether the maximum or minimum exists or not. Okay.